So we're going to be talking about malicious SSH. This should be fun. We have a lot of fun graphics. All right, yeah. So first, who am I? I'm Daniel. I'm a second year. People seem to forget that sometimes because I'm just so incredibly based and humble. I do red teaming and pen testing. I'm doing CPTC this year with our wonderful team. If you're interested in pen testing, definitely check out CPTC and come to RBACT. I co-opted at Red Canary over the summer, which was a really cool experience and a lot of fun, and that's my Discord if you have any questions. Cool. Oh, and I'm majoring in CSEC, did my minor in mission. Okay. So first, we're just going to do like a quick SSH refresher because, sometimes you just forget some basic things. So SSH, really what I'm referring to is Open SSH Portable, which is this open source project that allows you to do remote authentication to different machines on Linux. Mostly works with Windows too, but we'll mostly see it on Linux. And there's like multiple binaries involved with OpenSSH. The three ones that I'm going to be talking about are SSH, which is the client, right? It's what you use when you want to authenticate to another machine. SSHD, which is the service, it's a listener on the box that you're authenticating to. That's how you can think of it. And then SSH-Agent, which is the service that kind of manages all the keys and identities and ties that all together. So first, let's just kind of go over some basic SSH Asymmetric Key Authentication. They teach us in CSEC 140. I'm not going to spend too much time on it, but yeah, just as a refresher, right? So we'll start with Black Spy over here. He has his private key in that directory, right? And then we have White Spy with Black Spy's public key and his authorized host file, which is the file that you just copy and paste all the public keys that you want into there. So let's say that Black Spy wants to SSH on the White Spy's box. He's going to try to SSH. It's a TCP connection. White Spy is going to get that. And then White Spy is going to respond with, he's going to encrypt a secret message using the public key that he has, which is Black's public key. And then he's going to try to send that back to Black Spy, right? So Black Spy gets that, and then he uses his private key to decrypt that secret message. He sends it back. White Spy will get that message, and then he will decrypt. He'll verify that the message is what he originally encrypted using the public key. He verifies that, and then if it's the right thing, he sends it back and we start the session. And I believe they'll also send a asymmetric key, which is what they'll use to actually encrypt the actual session, right? So that's how that works. Pretty. You learn this in CSEC 140, asymmetric key authentication. So refresher, cool. Now let's say, how would a red teamer take advantage of this in order to, do malicious things? So enter the cowardly dog, and he has a private key as well, and it's Black Spy's private key. So he has that on his box, and he can use that to SSH onto White Spy because White Spy has Black Spy's public key. So he's going to kind of pretend to be Black Spy here. And all he does is SSH. He uses TACI in order to kind of say, hey, I want to authenticate using this cool private key I have. And then White Spy will allow him to do that, right? It's using the same process that we just went over. Alternatively, if Courage just has his public key inside of White Spy's authorized host file, then you can just authenticate directly too, right? So, if you're blue teaming, definitely look at your authorized hosts file. Make sure there's no weird SSH keys in there. And yeah, so that's just a very fundamental, basic way that red teamers are going to use SSH in order to have persistent connection, right? And now let's kind of move into some more fun ways of looking at this. So along with SSH, you can just recompile the binary. You can do this with a lot of things because it's open source, right? So just go to GitHub, you clone OpenSSH, and then you can edit the code however you want it and recompile it. You can do that for all sorts of things on Linux. So you can recompile SSH-D, the service, right? So this is the listener. You just straight up have a password backdoor. So you can see it's very simple. That red box is everything that I added into the SSH, into the auth password file in OpenSSH. It's just saying, hey, if your password is this space, return 1. And 1 here means success. So you just authenticate very simply. And since this is just a recompiled binary, this is very hard to detect for if you're blue teaming. You can do like some kind of file integrity check with like checking the SHA-256 if you wanted to. And yeah, if you wanted to fix this, you would just have to like reinstall SSHD, which can be a pain in the neck in the middle of competition because it is a service that you need to keep up a lot of the time. So this is a fun thing that red teamers like to do, is just recompile stuff. Yeah, but what I really want to talk about is SSH multiplexing. So I love SSH multiplexing. I don't think, like historically, I'm not sure if we did this a lot in red team before, but we're definitely going to do it now. It's a lot of fun, and you'll see why. So let's say we have Anthony over here, and we have Kenny, Mr. Anderson. So Anthony wants to SSH on a Kenny, right? So he says SSH Mr. Anderson at his IP address. If he has multiplexing configured, and I'll go into exactly what that means and what that looks like. But for now, let's say, okay, Anthony has multiplexing configured on his box. What that does is that it creates a socket on his machine, and connecting to this socket is going to allow whoever connects to it to reuse that same SSH connection. Not the same session, but like the same TCP connection, right? So they'll go onto that multiplex socket and then get their own SSH session. And the best part is that it's completely unauthenticated, so you don't have to give a password, right? So now let's say we have a red teamer, Braden. And Braden has a shell on Anthony's box through his C2 or SSH or whatever, right? He has remote command execution on Anthony. Braden, what he can do is connect to that TCP socket, that multiplex socket, right? Using this kind of specifying the control path where he wants SSH and specifying the user and IP that he wants to authenticate to. And you can go through that multiplex socket and get a box on a Kenny. So it's kind of like a worm, right? And it's all unauthenticated. He doesn't have to type in any password. He doesn't have to put a key anywhere, right? Like as you can see, there are no keys in this graphic this time. This all works with either key authentication or with just password authentication, which makes it really flexible and very cool. So more specifically, let's kind of look at what this looks like. Yeah, again, this is it in text where we're using an existing TCP SSH connection. It creates a socket, no authentication required. And these are like the configuration settings you need to put. So control master has to be set to auto. Auto means just try it with like a master connection. If that fails, just open a new one. You can set it to yes, and you can get most of the same results, but auto is just better for like what we're doing maliciously. Control path. So this is just the path where you want that socket to be created and where it's going to be. Yeah, and then control persist just means, okay, keep that socket alive after the original SSH connection quits. If you don't set this, then after that person is done SSHing onto that box, the socket will go away. So we set that a yes, so that doesn't happen. And yeah, so to specify these different options, you can put it in the configuration file, or you can just set them when you run SSH, right, like on the command line. So, but how can a red teamer like do this and trick a blue teamer into running these SSH commands so that the stuff gets configured the way they need it to be? There are many different ways to do that, many different ways. So let's kind of look at some of those. Yeah, so we need to be sneaky. So obviously we can just create like a bashrc function, but that's kind of boring, and blue teamers are definitely going to find that very quickly. They're looking at their bashrc file. We can mess with the configuration files. This is like slightly better, but blue teamers still tend to monitor their config files and make sure that red teamers aren't doing anything crazy with it. And we can replace the SSH binary with a bash script. This is kind of like a more convoluted way of doing it, but it flies under the radar sometimes. But like if they're doing any kind of file checking on their binaries and if they're doing good logging, then this will be caught pretty easily. We can recompile SSH, kind of like how we recompiled SSHD earlier, which is much more stealthy and much more of a pain to fix. It's not too bad, but it's still a process. Or we can get really fancy and do like an exec hook with a rootkit. And I didn't put in the necessary time to figure this one out quite yet. But when I do, then blue teamers, you're just kind of screwed at that point. Gonna be real. So yeah, let's take a look at what those actually look like, right? So bashrc function, very simple. It's bashrc function, we're just saying, okay, call SSH, give these options, and then the last argument that's in the end, the $sign @ sign, was just saying, yeah, include all the original arguments that the person gave, right? So it would run SSH with all of our stuff, and then it would also tack on whatever address they put at the end. But again, that's too obvious. So we can do some stuff with the config file. And when I mess with config files, I like to do an include a file, and then use that file as like my malicious config file. I just feel like it's a little stealthier, so you can just put this anywhere in the configuration file, and it typically won't catch it. So yeah, you just do that, and that's what it looks like. Say host star for every single host that they use SSH to connect to, and they just set those options, right? But again, not too stealthy. So what's more fun is if we replace the SSH binary with the bash script. So this script is going to like create a hidden directory. It's going to move the original SSH to that directory, and it's going to give like all the right permissions and everything. And it's going to create it's going to echo that command into evil SSH here. And evil SSH, you can see the variable over there, is just where we're going to put this. So we're just going to put it where the original SSH was. So that's why I set the user bin SSH. And then we give that the right permissions. So now whenever they run SSH on the command line, it's actually going to run this command that we echoed into that, right? So that's fun. Yeah, and then the last two lines are just automating this whole thing where we're putting in config files. But yeah, so this is another way to do that. You're just replacing the binary with a bash script, right? Slightly more stealthy. But recompiling, this is very stealthy now. So we had a little fun with GDB debugger to figure this out. That was fun. And then you can see here, so when I'm recompiling SSH, that first box, that first picture, what I'm doing here is setting the control path, which is a string, right? So that first line, that was originally if the control path is not equal to null. So if the user didn't specify a control path when they ran SSH, then execute this. I set it to if 0 equals 0, and last I checked, 0 always equals 0. So it's just always going to run, if true. And then the line right under that is the only line I added to that if block, where I'm just setting the control path to what I want it to be, right? So now whenever they run SSH, that's what that control path is going to be set by default to that value. It's just hard coded. Yeah, and then picture under that is in the readconf.c file, where I'm just replacing the default options again. So I'm setting master to auto from when it was -1, which just means it wasn't set. And I'm setting control persist to 1, which is just saying set it to yes instead of unset, right? The original was -1. And that makes it so that whenever they run SSH, it just has all these malicious default options. And we get a free multiplex socket that we can connect to without authentication, and we get a shell. Sweet. So now I want to talk about SSH-Agent hijacking. You might not see this in a red team blue team competition just because it requires a bit more setup. But I found this by going through the man pages, and I looked at this pack-A option, and it straight up just tells you, yeah, an attacker can potentially use this in a malicious way. So I was okay, I want to look more into that and what exactly that means. And I came across some pretty cool articles describing this somewhat kind of a vulnerability of how this could potentially be used maliciously. So that brings us to another fun graphic. We'll have Enzo. In this config file, he has forward agent set to yes, which by default that is not the case. So you see that in your SSH config file, definitely be a little suspicious. And then we'll have Ishan. And Ishan, it's important to note, he has Enzo's public key in his authorized host file, right? And in his SSH config, he has allow agent forwarding set to yes. And this is actually, at least on my Ubuntu box, it was the default, it was already set to yes. I don't know if that's usually the case, but yeah, I mean, that's a thing. So now let's say we have Enzo wants to connect to Ishan, right? This is totally normal connecting. So he SSHs onto Bozo over here using the authentication, using that same process that I described back in that first graph, right, with the spies. So he gets his SSH session. That's great. But now let's say that he wants to SSH onto the White House from Ishan's box, right? And let's say the White House also has Enzo's public key. The problem here is when he's on Ishan's box, Ishan does not have Enzo's private key. So that makes the asymmetric key authentication not possible normally because there's no way to decrypt the message that the White House is going to send to Ishan using the public key that he has for Enzo, right? And Enzo probably does not want to keep his private key stored on Ishan's box because that would be an obvious vulnerability. You know, you want to keep your private keys on your own boxes. So if he doesn't want to use password authentication and he wants to SSH from Ishan onto the White House, and for some reason he decided not to use like a jump server and just do it like through SSH key authentication, he would have to set up forwarding, right, which is what those configuration options are. So the forward agent set to yes, and the allow agent forwarding set to yes on Ishan's box. Now, what that allows him to do, so he'll SSH onto the White House, he'll send that command, and the White House is going to, so that command is going to create like an SSH, sort of like a tunnel between Enzo and Ishan. And then when the White House wants to like send the encrypted message back to Ishan with like, say, hey, encrypt this and then I'll let you authenticate to me, it'll send it back to Enzo actually using that tunnel, right? That SSH-Agent set because we have those configuration options set. Cool. So he goes to Enzo for the private key now through this tunnel. Enzo is able to authenticate, and let's say we have a red team, right? So math has entered the equation, and he has a shell on Ishan by whatever means, maybe it's a C2, whatever, right? He has a shell. And let's say he has root access. By having root access on Ishan, he can actually just do this really great thing where he can kind of pretend to be Enzo, right? So he's going to run these commands. First one is just saying, okay, let's look for all processes. We want to find the bash process that's connected to the SSH process that Enzo is using on Ishan's box, right? So he's looking for any kind of SSHD process that's running under the Bozo user to find that shell. And once he has that process ID, he can just cat out use that process ID to cat out that file and then search for this variable here, SSH auth sock. And that's just like the socket that tunnel is using. And then he can run SSH. He can like first apply that socket. He's going to set it equal to whatever this command returns, right? And then he's going to use that to SSH to the White House at IP. And he'll be able to do that by tricking, the White House into thinking that he's Enzo, because he's using that tunnel that connects to Enzo's box, right? So now he has a shell on the White House. So that's SSH agent hijacking. Like I said, you might not see this in like IRSec or something because there's like a lot of keys that have to be placed and things that have to be set. But it is a real attack, and this does actually happen. And I just figured this out by looking at man pages. So definitely read the man pages. So looking to the future, right? What are some more things that we can do with SSH? Because this stuff was pretty not too advanced. This is just like using what SSH already kind of gives us, but tricking the user into doing things like supplying bad configurations. So what's some cooler stuff that we can do? I found a pretty cool article talking about messing with the dynamic linker once like stuff gets compiled. Like there's this silly tag called debug that you can just set to needed, and then it'll load whatever library you want it to load. So you can mess with that kind of stuff. You can use ptrace. I'm going to become a ptrace god. That's the next goal. Become a god at ptrace, and then inject stuff, right? Which is just what GDB is doing, but we're going to do it maliciously in real time. And then, I also found like some other cool projects where they're spying on active SSH connections using like fancy keylogging stuff to simulate an actual like spying type thing. I'm going to recreate that hopefully in Golang because they did it in Python and Python things can't be compiled. So I want to do that in Golang just to make life easier. So there might be a sequel to this presentation. Who knows? Well, depends on if I actually get this stuff done. Here are my sources, and there is some basic SSH malicious stuff that red teamers like to use. And if you're going to be blue teaming at IRSec, definitely keep your eyes open for those things, especially the multiplex stuff, because I do plan on doing that. And if I see any of you that are here not like taking care of that, I will be disappointed. So I just told you everything you need to know to make sure that does not happen. Cool. Thank you very much. That's a presentation.